we will wait until the RTMP stream buffers.
Okay, so we have laughing and sad. We can.
And we're live. I
live.
am
Wow.
here, live streaming from the Voice and Video AI Hackathon at Solaris AI this weekend. I roped Charles in as a judge because who better to be a hackathon judge these days in the year of our Lord 2024? And why would I possibly say that? Introduce yourself. What do you do? What do you work on?
Yeah, hey everybody, my name's Charles. I studied neural networks in grad school at Berkeley a couple years ago, and that turned out to be a good choice. And so now I work at an infrastructure company called Modal that does serverless infrastructure for data, ML, and AI teams. So spent a lot of time thinking about GPUs, thinking about how to make them go burr, and how to build applications out of these awesome foundation models, whether that's voice and sound models or image models or language models. How do we take them and make them into cool shit?
So I'm going to butcher this because I'm like a C programmer who writes Python now under duress. To me, Modal's claim to fame is infrastructure with a layer on top that lets you annotate a Python function with a something.
Yeah.
What do you call that in Python?
A decorator.
A decorator. Yes. Okay. Now I'm comfortable because that's like an old school computer science term that they actually pulled into the Python world.
It's a way to write higher order functions that doesn't scare people who are still still learning to program.
That's a good thing.
Yeah, it's a good thing. It's a good thing. Sometimes I want to write higher order functions like chain them together or something. But then, at some point that would probably all come crashing down. Yeah.
You want raw combinators.
Yeah. If we, maybe we should launch a combinator sub SDK. Let's get on that. For all the Haskell refugees, now working on
That's
on
me.
LLMs.
That's me. So you can write these Python functions, and then you add this little @ on the top.
Yeah.
And then they just run in the cloud.
Yeah. That's the idea.
So how does that work in 30 seconds?
Yeah. Okay, so basically we run the Python code locally, and we collect up everything in the global scope, including these decorative functions, and then we phone home and we say, okay, here are all the things that somebody asked for. This function wants a GPU, this function wants a remote file system, and then when you go to call that function, we are ready to we re-execute all the code in the global scope, so we have that function's definition ready, and now we can run it on our infrastructure. So we re-execute that global scope code that we executed locally to find out what all your stuff was. We re-execute that on a machine with an H100 or on a machine that can access the remote file system. And then we run the interior of your function. And then that's inside of a container, we have all of that spun up and ready to go, so that instead of that process taking many minutes, which is what happens if you need to rebuild a Docker file, push the Docker file to a registry, pull it down, then send inputs to it and get outputs of it from it. That can take many minutes. At Modal, we have it all set up so that takes a second the first time and milliseconds on future calls.
And then I get billed for that GPU time or that CPU time by the second.
By the second, basically. Yeah. And kind of the appeal there is the classic serverless thing. It's I need the whole GPU. I need it for 5 minutes, but I don't need it for an hour. I don't need it all day, or I need 10 right now. I need 100 in an hour. I need only one when my users are sleeping. And that, that usage, pay for what you actually use, not for what you are required to allocate.
And what are the use cases that you see kind of using this kind of infrastructure at scale?
Yeah, I think there's two categories. One is stuff that does a lot of scale to zero, where sometimes you need it, sometimes you don't. A lot of those things are trading jobs up to 8 H100s, or data processing. You want to scrape the web, pull down a bunch of data, run it through GPUs to turn it into vectors to create an index over it, and then you maybe do that once a week, or you do it irregularly, and then during that time you need a ton of infrastructure, but then you just need to spin it up, spin it back down. And the people who want to do that are frequently data scientists, ML researchers, people who have a PhD, but it's not in Kubernetes, and so they don't want to set up all the infrastructure that's like a whole extra job on top of what they really need to do. And then the other side is auto scaling inference infrastructure. Like with training, you frequently have like, oh, I need like 100,000 H100s for 1 month or 6 months. But maybe you don't frequently need 100,000 H100s, but you frequently need like 128 H100s for a couple of weeks, couple of months. That is very different from inference, where like you hit the front page of Hacker News, and now all of a sudden you need another 128 GPUs for like a couple of hours during this hug of death, and then you don't need them anymore. And so we have a lot of people who like train their own models. They have their own like supercomputer, basically their own InfiniBand connected H100 cluster, and they've like trained a model, but they want to like keep training more models. They want to keep using that for that like training, for which that kind of infrastructure is a really nice fit. And then they don't want to like cannibalize those GPUs, cannibalize their internal talent to like build an inference platform, where like then they would have to solve all these hard problems of like even like humdrum hard problems of like getting GPUs from cloud providers and like using their APIs, spitting up virtual machines, getting models loaded onto them. All that stuff is really hard and like a distraction from the core value of their business, which is like making these really great models and then building a product experience around them. So those are the two places where we found this infrastructure like really, really shines right now. And there's just like not really other great options. Other serverless providers are not oriented to the same data intensive workloads, and other like GPU providers are not oriented to the same like speed of auto scaling and the same like flexibility and ease of use of scaling up and down from zero.
What are the best Kubernetes grad programs right now?
Oh yeah, probably at this point, I bet the Cloud Native Computing Foundation does have a PhD program.
You would think
The
so.
Linux Foundation they really can spin out some big programs.
Over my dead body, we ported all of our major workloads at Daily to Kubernetes a year and a half ago or something. I was the last Kubernetes convert in San Francisco.
Nice. Yeah, I mean, yeah, I've never personally had to like manage a K8s cluster. I like built one out of like Raspberry Pis and MacBooks at home to like understand it, and I was like, wow, this is pretty cool, but it also has been pretty painful, and I don't want to do this again. So I think more seriously, the particular thing that it doesn't fit for is like these heterogeneous compute. So like GPUs are kind of like second-class citizens, and Kubernetes is very like painful to use them. And then for like these like one-off, like the first workload type that I described, like, oh, I need to like run this job and then spin it back down. Like Kubernetes, like part of the like declarative infrastructure is like there's a state of the system that I want to like anytime I deviate from it, like come back to it. And that's great for like standing up a database. It's great for standing up a web server where there's like a sort of relatively static thing that you keep up, but it's not great for like running a workflow. There's like these things are also like second class citizens in like Kubernetes world, and people have built things on top of it, but it's like it's a tool designed for a specific purpose, and it's not that.
In all seriousness, we had gotten to the level of stability and maturity and multi-cloudness in our global infrastructure that we absolutely needed to sort of standardize on Kubernetes for a whole bunch of reasons, including that the hyperscaler support for Kubernetes is actually now much better than for their own proprietary tools that they grew up hoping that they would have proprietary lock-in for those tools. So you do need Kubernetes, but I also think
and we use it. We don't use it for our core scheduling. We built our own scheduler for just because speed, and like again, it's like not good for certain kinds of tasks. But we do use it for managing a bunch of our like core infrastructure, like making sure that components of our like web server are up, our databases are up, like it's great for that.
But I do think it's an example of essentially everything in the entire tech stack now is going to need to evolve. Everything that was built before the LLM era is going to have to evolve in ways that most of those tools are a little bit not super well suited to evolve towards because of the needs of a bunch of different parts of the LLM stack that are just very new, from the GPUs to the fact that everything is stochastic now, to different kinds of shapes of network access.
Yeah.
And I preach this sermon all the time, and I'm still not like I still don't. I think I feel like I'm still wandering in the wilderness. That like HTTP APIs for inference are not actually what you want for inference.
Oh,
And
interesting.
a lot of stuff is going to have to evolve over the next year.
Yeah, I'd love to hear more about that sermon, because I've mostly just been like you standing up little OpenAI API compatible inference servers and happy with it. Though, yeah, Modal does one of the things like you can set up like REST APIs. It's one sort of thing that you can set up on Modal, but you can also like fundamentally, really, it's a remote procedure calling service. It's like create this object that you can then kind of like import in another Python process and call like the way you would call a local function or methods on a local object. And so it actually like in some ways is like, yeah, like it's intended to be a good fit for things that for which like, web APIs are not a good fit. And it's fundamental, like everything is built on gRPC at the bottom, and the like HTTP layer is actually just built on top of that.
Well, I actually haven't even showed you this, but we're running some voice-to-voice workloads on Modal, and we're using the Docker container level stuff there
yeah.
because we're bundling a bunch of stuff that opens up UDP connections,
Okay.
and then we're moving streaming media around
Mhm.
with Modal's hosting as kind of a, as you were saying, a very flexible scale-up, scale-down hub for temporary workflows that take real-time data in, do some processing, push real-time data out.
Got it.
And we have REST API endpoints that are part of that stack, but as soon as
Mhm.
you're moving real-time audio and video around, you
I
also
see.
need this other layer.
Yeah.
And I think part of my sermon is just that the whole LLM world is moving towards multimodality. Even small models are doing vision, and vision is going to become video, and audio, native in, native out, and text is just one modality. And as soon as you have non-text stuff, you have you have new problems.
Yeah, it's exciting to have new problems because, then there's new jobs, If there were no new problems, then engineering would get pretty boring.
100%. We live in an era where we get to figure everything out again, and we're gonna get it wrong the first 2 or 3 times, and then we'll be retired and people will get it right.
Yeah, and the next generation of people will make snarky comments about the important infrastructure we built. Like, apologies to anybody who worked on Kubernetes. It's great.
Somebody in the Hackathon Discord pulled out of the Pipecat source code this weekend a comment that one of my colleagues made about me before we open sourced the code base, and it really made me laugh. But you said you have some new stuff you're working on that I haven't heard about yet. Do you want to tease that?
Oh, sure. Oh, yeah. I wasn't working on anything too interesting today. Oh, yeah. I can tease a little bit. I've been working. As the hat here currently says, I've been
CUDA mode.
going CUDA mode lately. I finally bit the bullet and read like all of the Boomer Core PDFs that NVIDIA has on their website about like, the CUDA C++ programming best practices, the definition of the PTX instruction set architecture, the professional CUDA C programming book, which has made a bunch of things more clear, and I'm hoping to release some like really nice material, like kind of just like collecting up a lot of that stuff.
That is so necessary.
Yes. It's nice. The information is available. You just like it's not exposed in the way that I think people like. It's not exposed as like an interlinked collection of hypertext documents as you would maybe hope. And so hoping to put something like that out soon.
It's also another example of this thing where there's layers and layers and layers. I mean, you can, if you've been doing the GPU programming a long time, you can see where they search and replaced from shader tutorials.
Oh, that's
when
funny.
they made the CUDA tutorials.
Nice.
Because it was all shader language before it was CUDA.
Yeah.
And it's
Yeah.
going to be something else besides CUDA soon.
Yeah.
Because it's so much more mass market, or whatever you want to call it now.
Yeah.
Like, and this work, it sounds like you're going to make it even more accessible, which it really isn't now, and that's
Yeah.
going to help it evolve to whatever the next thing should be. Although
Yeah.
I should ask you, do you think, so you're doing CUDA programming, do you think a lot of people should be, or are we just better off working at the, let's say, the PyTorch level?
Yeah. One thing that's become clear from examining the stack more closely is that really the like part of the stack that feels more like NVIDIA's moat that or like is the sort of like very hard to replicate component is actually something that looks a lot more like x86, the PTX IR, and the streaming assembler. And so it's like previously I had thought that stack was like more tightly integrated and that it would be really hard to like sort of disaggregate it. But over the last year or two, people have been building this like Triton, OpenAI initially, and now others building this like Triton compiler that targets these intermediate representations, and like takes advantage of the LLVM stack to sort of do progressive lowering down to that. It opens up an opportunity to write languages that are like alternative interfaces into that like more narrow waist. Well, it's not really a narrow waist; it's a narrow bottom because nobody else, because they just all terminate on NVIDIA GPUs. But at least opens up the like top part of the funnel, and it is not implausible to me that you can get like pretty good performance out of those, or like a pretty good ratio of like engineering time to performance, where you'll get good kernels out of Triton. I think the proof of concept for this is the Liger kernels, where the LI stands for LinkedIn. So somebody at LinkedIn was able to just like sit down, learn this like Python high level language that compiled into kernels, and then like it was still hard. Like it still took them, like the benchmarking was difficult, the correctness verification was difficult. Like they had a very subtle bug with like non-contiguous memory views. So it's not like it's suddenly this becomes like easy and anybody can just sit down and write a Kublas level kernel in a day. But it becomes feasible in a way that like writing that with the previous like CUDA C or CUDA Fortran stack would have been like entirely infeasible for that person. So I've hope for that, as well as just like increased attention meeting on this from people who want to open source things, meaning that we get more like super high quality open source kernels like Treehouse Flash Attention kernels, or the recent scale.product attention kernels in PyTorch 2.5 that are like similar quality.
That's really fun stuff.
Yeah.
Well, thank you.
Yeah, always a pleasure, Quinlan.